In this video, we'll see the analysis of cascode and cascade amplifiers using PSpice. The cascode amplifier is a two-stage amplifier that consists of a common emitter stage feeding into a common base stage. The input signal is applied at Q1, that is at common emitter stage, and output is obtained at Q2. AC signal is applied at base of Q1, which amplifies it with unity gain, and voltage V01 appears across collector of Q1. V01 acts as input to Q2, which further amplifies the signal, and voltage V0 appears across collector of common base configuration. This is a circuit diagram of cascode amplifier. A cascade amplifier is any two-port network constructed from a series of amplifiers where each amplifier sends its output to the input of the next amplifier in a daisy chain. The voltage divider can be formed by using the input and output resistances of the first and next stage. Using two or more stages increases the overall amplifier's voltage gain. This is the circuit diagram of cascade amplifier. Now let's see how to design and simulate cascade and cascode amplifiers using PSpice. Now let's start designing our cascode amplifier first. To open a new workspace, we'll go to File and New. So the new workspace opens up. Now we'll have to build a circuit by getting each of the parts. So to get the parts, we can either click on this icon Get New Part, or we can go to Draw menu, and from there we can click on Place Part. If we have already used the components in our circuit, we can just click this drop down box and we can get the different parts. Now to build our circuit, we need this transistor Q2N2222. So I am selecting that. The transistor gets selected along with the cursor of the mouse. We can place it approximately where we will have to start building the circuit. Here we need two transistors. So I am placing two transistors. So whenever we select a particular component, the part actually gets selected along with the mouse cursor. After placing the components, we can either right click on the mouse or press escape key to deselect the component from the mouse cursor. Next we will be placing the resistors. So you can select the resistor from the drop down box. So in case we have not used it previously in a circuit, we will have to go to the draw menu, click on place part, and from the libraries we can choose the required component. So I am placing the resistors to build the circuit. So whenever we need to change the orientation of the part, that is from horizontal to vertical, you can just click on Ctrl R. So now you can see the resistor alignment has changed to vertical position. And one more resistor over here. Then press escape. Next, I'll be placing the capacitor. Select the capacitor. One capacitor here and one more capacitor here. So this circuit I am building according to the circuit diagram we just saw previously in the slide. Next we will have to place the source voltage and the VDC. placing BDC. Now we have placed all the components. We'll have to connect them using wire. So this is the icon to draw the wire for connecting the parts. You can either click on this or we can go to draw menu and select wire from here. Place on the node from where you need to start connecting. Click on that part, on that point. Then you can see a dotted line being created. Again, from where you need the ending point of the connection, again there you click again. So now both the nodes are connected. Similarly, we will be connecting the other parts as well. Now I am selecting and placing the ground terminal in the circuit. Okay. Now we'll have to give the specific values for each component. Now each of the component you can see they are having the default values. Like resistor, the default value is 1K. For capacitor, the default value is 1 nanofarad and so on. So now we'll have to give the values as per the circuit diagram. This resistance value is 80K. And this resistance value is 4.7K. Capacitance value is 10 N and this value is also 10 N. This voltage is 20 volts. This is 1.5 volts. And this is 0.1 volt. Now let's place a voltage marker over here and save the circuit. Now after saving the circuit. Let's simulate it using the simulate icon, or we can go to analysis and click on simulate. Before that, we'll have to do the analysis setup. So here we'll have to click on enabled and select AC sweep. Here click on decade and give the points decade as 20, starting frequency as 1 and end frequency as 100 megahertz. Click on OK. So this is the frequency response of Cascode amplifier. Similar to the design of Cascode amplifier, we'll be placing all the parts for Cascade amplifier according to the circuit diagram. Here we have used two FET, J1 and J2. So we'll be selecting the required field effect transistors from the library and building the circuit and place all the components and give the specific values for each of them. And we'll place the voltage markers at these two nodes. After building the circuit, we'll be simulating it. So first we'll be setting up the analysis. Enable AC sweep. Select AC sweep type as decade and points per decade is 10. Starting frequency is 1 and ending frequency is 1 gigahertz. Now we'll simulate the circuit of Cascade amplifier. Now this is the frequency response of Cascade amplifier. So thus we have designed and simulated Cascode and Cascade amplifiers using PSpice and analyzed the frequency response.